want to talk about the arc tangent, the arc cotangent here for a minute. So this is cotangent, and I want to start here. And you can see here that cotangent has asymptotes at 0. I didn't put it in because it had the axis, and pi. And when we do this, we've talked about the arc, all the trig functions. We're taking certain parts of this. In the case, if you look at how the arc cotangent is defined, they just define it from 0 to pi. They just want this first chunk, okay? It's the first and second quadrants. Now, the problem is that the TI doesn't do a great job of moving it. So if I put this in and I do arc cotangent x, it has taken this first one, it's put it up here nicely, it looks beautiful. This is actually the same as this, the arc tangent of x. You can see that's the exact same line. It just covered over it. And this is a useful fact because, well, Desmos does a good job of this. If you've got your TI out here, and I go in here and I put in 1 over x, this is how I get cotangent, remember. So cotangent, you don't have a button for, so you have to solve for it. When I go to graph this, and I'll think about it, it tries to take pretty much negative pi over 2 to pi over 2. It tries to take this middle, and it has this asymptote in the middle. And it's just ugly. So the solution is to graph, it's not nice like Desmos, and I can't use my keyboard, pi over 2 minus the arc tangent of x, and then I'm going to get that nice same graph like I got on here. So it's just a trick really to get the calculator not to take the same one. It's just a programming issue with the TI that they fix in something like Desmos. The thing you have to be careful on with all of these is when you're putting it in and you're rearranging them, and as I said, like Desmos makes it really easy because it actually has, if you come down here and go to functions, it actually has all 6 of the inverse trig functions. And so you don't necessarily have to do it, but with the TI you do, and so you need to solve for them. And I had my stylus here a few minutes ago, and I buried it under like 5 layers of stuff. So when I go to rewrite this in terms of one of the basic ones, I do have to consider this. So this here then is the same as the cotangent of y equals x, and then 1 over tangent y equals x. Now you can at this point realize that these flip-flop, or you can solve. This is 1 equals x tangent y, so then 1 over x equals tangent y, so then y equals the arc tan of 1 over x. Now if there's something else in there, if it's just not an x, you will have to really pay attention to the algebra here, and this is where it really behooves you to have it written out nicely. And our trig assignment does cover some of this, kind of making you work with that a little bit and go, oh, I got to be careful. For instance, if this was an x, say this was not that, minus 2, well then as I come down here, there's my minus 2, right? There's my minus 2. There's my minus 2. There's my minus 2. And then so that's what I'm actually putting in. And again, if it's outside, it's going to affect it differently. And you do have to make sure you're really paying attention to how it works. So definitely as you're putting into the TI, there is some algebra that goes along with it, and that pi over 2 minus the arctan of x is a really nice trick that makes your life a lot easier as you're working with it. So it's just one of those good things to know. But if you are using Desmos, it'll kind of let you cheat because it'll do the arc cotangent, the arc cosecant, and the arc secant for you without the conversions. So you can also, it's a great way to check yourself too off your TI. So just some thoughts, but just like all the inverse functions, they are only going to be defined for certain areas, and there's a whole list in your book in section 6.1. It's important to make sure you know which quadrants it's defined for. In this case, cotangent is only defined for the first and second quadrants. And so it's interval is only from 0 to pi. So you do have to really pay attention to those because that's how they often can trick you too on the problems you're solving. You're like, well, normally I'd have 2. Well, you probably only have 1 because it's only defined for 2 quadrants rather than 4, like our typical trig functions.